Welcome to the g.c.2.9 notes. We are going to look at the relationships between angles and the arcs in a circle, and we're going to look at angles specifically whose vertices are outside of the circle, as you can see in the first diagram, inside of the circle, as you can see in the second diagram, or on the circle, as we've already seen with inscribed angles. But if you look a little further down, that's not the only type of angle that forms a relationship where the vertex is on the circle. A vertex can be on the circle by a tangent line intercepting a secant line. And so if you look at the diagram here, our tangent segment is formed at point B with the secant segment that's formed by, let's say, line BD. And these angles 1 and 2, as is written to the left, are going to be half of the arcs that they intercept. So angle 1 is going to be half of the major arc, and angle 2, if I maybe color it in a different way, maybe with orange, that is going to be half of the arc it intercepts. And so we'll dive right into a few examples. There are some that are completed for you. If you look at example 1 in the Now You Try It section, we have that we want to solve for angle 1. We are given the major arc is 248. That means that this minor arc is going to be 360 minus 248, which is going to be 112 degrees. And since this angle intercepts that arc from a tangent-secant relationship or even tangent chord, angle 1 is going to be half of the arc it intercepts, so it's going to be half of 112 degrees, which is going to be 56 degrees. If you look at the second diagram here, we have that angle 1 is inscribed to this arc here. You also see, hopefully, that 61 is inscribed to this arc that I'm now bolding. So 61 is half of 122, and angle 1 is inscribed to that arc, so we have that angle 1 is going to be 61. This does extend from a previous lesson where if both of these angles are inscribed, if you will, to the same arc, then they're going to be congruent. And looking at the last example in this section, we have 96 as this minor arc. We want to figure out what angle 1 is. I see I have a diameter drawn, and so I know that the semicircle is going to leave this squiggly arc, minor arc, to be 180 minus 96, which is going to be 84 degrees. And so 84 degrees is the arc that angle 1 intercepts, means that the measure of angle 1 is going to be half of 84, which means that our angle is going to be 42 degrees. If you look at the next part of the notes, we're looking at angles that are formed inside of a circle. We've seen central angles before, but now we're going to look at angles formed by chords intersecting, for example, or secant segments intersecting. And the relationship is that the angles that open up to the arcs that they intercept are going to be half of the sum of the arcs. So angle E measured by AEB, or the vertical angle CED, is going to be equal to half of AB plus CD. So let's go ahead and jump into a couple applications. If you look at the Now You Try Some section, you have some examples completed for you, but it's a little bit more meaningful to try it out yourselves. We have that angle 1 opens up to, and the angle that it's vertical from, the arc 60 degrees and the arc 150 degrees. That means that angle 1 is going to be half of the sum of the two arcs that they intercept. And so we get that angle 1 is going to be half of 210, which means that angle 1 is going to be 105 degrees. If you look at the second example here, we have a similar relationship, but we have that the angles that open up to the arcs that are given to us are supplementary to angle 1. So once we get the missing angle x, let's say, we would do 180 minus x to get angle 1. So x equals half of 75 plus 104, excuse me. And so x is equal to half of 79 if I could do some math, which means that x is going to equal 89.5, I believe. And so 89.5 is supplementary to angle 1. And so we want to do 180 minus the 89.5 to get angle 1. And so that means that angle 1 is going to be 90.5 degrees. And looking at our last example here, we're given kind of a reverse situation. So we're given the angle or the vertical angles that open up to the arcs, but we don't know one of the arcs. So setting it up as we have the previous two examples, we know 100 is going to be half the sum of the two angles. And so from here, to solve for, I'm going to use x instead of 1 just so I don't think it's a value or a measure of an angle. I'm going to go ahead and solve it and try to do it efficiently. So I'm going to multiply both sides by 2 to eliminate the half, and I get 200 equals 136 plus x. And from here, if I subtract 36 from both sides, I get 64 is equal to x, and I am done. 64 degrees for the measure of x. If you look at this last concept here, we're looking at angles whose vertices are outside the circles. We have a few situations that give this to us. We have a couple secants can intersect and form a point of intersection outside the circle, a secant and a tangent, or a tangent and a tangent. Every single time when the vertex is outside the circle, it's going to be half of the difference now of the arcs that it intersects. And so half of AB minus CD would be the measure angle E. So some examples are worked out for you. Let's go ahead and try some out ourselves. This is the most basic example you could see. We have angle 1 is outside of the circle and intercepts 107 and 40. So measure of angle 1 equals half of the difference now, not the sum, which means measure of angle 1 is going to be half of 67, which is 33.5 degrees for the measure of angle 1. Looking at this next one here, we have a relationship where we're given half of a circle, really. We're given 90 for one part, and if we're given these congruence tick marks, then we know that the other parts are 45. And we want to solve for an angle outside the circle, and now we have enough to do that. We have that 90 and 45 are the arcs that that angle intercepts. So measure of angle 1 is going to be half of 90 minus 45. And so half of 45 is going to be 22.5 degrees. And looking at our last example, we have one of the arcs that angle 1 intercepts. We don't have the other arc, but we do. We just need to take away the 114 and the 68 from 360. And by doing so, we get, I believe, 178 degrees. And so now we can set it up where we know that the measure of angle 1 is half of the difference of the two arcs. And so we know it's half of 110 degrees, which is 55 degrees.